This we had done, right? Yesterday. So good morning once again, all of you.
Morning.
Let's start. Yes, Zamin Raza, please start the reading.
Yes, ma'am.
Please
Balanced
put off your
force.
mic. Start the reading, better. Start to
Balanced
read.
force. If the resultant of all the force acting on a body is zero, the forces are called balanced force.
So what are balance forces? Now, I'm applying many forces on a body, right? What I say? I'm applying not one force, but quite a lot of forces on a body. And when I add up, it is zero. So that force becomes the balance force. You understand? For example, look over here. This is an object. This is an object, right? Is being pulled on either side by applying force. Got it? You understand better? So there is even a force which is exerted by the table. Can you see this? There are three forces. This is one, this is two, and this is three. When the net, because the force which is working, and another force which is working is the fourth force. This is the fourth force. So one, two, three, and four. You understand? So when the result of all these four forces becomes zero, we say that all the forces are balanced forces. Understood? Hello, boys.
Yes, ma'am.
Yes, understood, all of you? So this is an object. We will go one by one. This is an object, right? So I'm pulling over here. You are pulling on the other side. The object is not moving. Remember that. Because it's an equal force that is applied on the body. The table, the object is on the table. So the table is exerting certain force to the object. But object is also being pulled by the gravity. So the another force which is unseen is acting on the body. So in all, we have four forces acting on an object. So the body does not move. Got my point? The body will remain at its place. Any problem?
Ma'am, which force is applied by the table on that object?
Frictional force, I hope you understand that. We are pulling it, isn't it? The frictional
Yes, ma'am. Yes,
force
ma'am.
will be sliding on both the sides, maybe. But if
Hmm.
it is equal force on, if F1 is equal to F2, then the object will not move. I think I taught you earlier. Remember? If it is unbalanced force, if F1 is more than F2, then the body will go on to this side. What do you say? And if F2 is more than F1, then the body will go to this side. I taught you earlier, remember? It's like tug of war, the rope pulling, remember? Five people on the on either side, and who will pull the others will be a winner. I think you played all these games.
Yep, ma'am.
Okay, so you understood this much? If at all you have any queries, let me know.
Okay, ma'am.
Anyone else wants to ask anything? So in all, there are four forces applied. Two forces on either side. Either side means one on left and one on right. One force is applied by the table onto the object that I told you, which is frictional force, and the object is being pulled down by the gravity. So there's the four forces which are applying on the object. And what happens? The object does not move because All the forces get balanced, and when we add everything, it becomes zero. You understand? So these are called as the balanced forces. Yes, please read with us.
The block on the table is acted upon by many force. Force F applied by the left hand is being balanced by the force F applied by the right hand. The weight W of the block is balanced by the reaction R on the block.
So you understood? Hello? Did you understand? So what is happening? This F1 and F2 balanced, equal, right? Up one is F3 and this one is F4. So F3 is equal to F4. You understood now? You understood now? So everything is balanced. Left, right, top, bottom. And the body does not move. Did you understand or do you want me to redo it again?
Understand.
Okay, thank you. So how many forces are actually applied? Four. How many forces are applied? One is
Four.
Four.
left, right, top, bottom. You understood now? On one object. And while reading, if any of you can make me understand, or you want to say something, or you want to elaborate, you're welcome. Okay? So if Sitin or anyone, Jishan, anyone is reading, and your colleague, any one of you, wish to explain those points, you're welcome with it. Okay? Hello?
Okay, ma'am.
Okay.
Okay. Fine. Start better.
When a body at rest is acted upon by balanced force, the body is not displaced. Example, the body remains
It is not example, better. It is that is. What
that
you will
is
say?
that is the body remains stationary.
Okay,
Second,
explain. Just a moment. First point. Can anyone explain this point? Yes, boys. We did just now. Can anyone explain in just two lines?
Yes, ma'am.
Yeah, shape it.
The force are
Explain.
equal from right and left and
Okay,
top and bottom,
very good. So what happens?
and that's why the body remains stationary. Means body doesn't move.
Great. The body was already stationary. You agree with me? Hello? The body was
Yes.
already stationary. The body was at rest. But what we have
After.
learned earlier, now what we have learned earlier, that when an external force or effort is applied to the body, if it is at rest, it will start moving, isn't it?
Yes.
This is what we have learned. But now what is happening? And those were only one force. Now we are talking about so many forces. And which type of forces? Balanced forces. You understood now? So left is balancing the right and top is balancing the bottom. You agree with me? Hello?
Yes, ma'am.
Yes? So what happens? It does not move. The body does not move because all the forces are balanced. Well done, Peter. Thanks. Now we start with the second. All of you understood the first point? Ninth standard?
Yes, ma'am.
Let's start with the second point.
Second point, when balanced force act on a body moving with constant velocity, uniform motion, they do not produce any accelerations on the body. That is the body continues to move with the same speed and direction.
Okay. Let's do the example.
Example, when raindrops fall from clouds at a greater height, the drops at first gain velocity due to gravity of the earth.
Can anyone explain the second point? Very simple it is. It's absolutely like the first one. Only little bit of difference is there. Can anyone give it a try, better? See, I wish that you try to express in your own words. Doesn't matter if you go wrong. I'm there, better. But do try. You will enjoy. I guarantee you will enjoy. So can I have the explanation of the second point? Yes, can anyone, better? Can you hear me?
Yes.
Yeah, then just give it a try. And you will be surprised to find yourself explaining in such a beautiful manner. Start, better.
When a body is moving and
You can take that example also, the example that we did just now. That example, with the example, you can explain. If you're finding it difficult, you can take the example and explain. That's what I said. So when a body is moving with a constant velocity, now what is the meaning of constant velocity? Uniform
uniform
motion, right?
motion.
Exactly. That means the distance covered is in same time, right? Same distance, same time. You agree? Because we know velocity is equal to distance upon time, isn't it? Hello?
Yes.
Yes. Velocity is distance upon time. So same distance, same time. It is uniform motion. What happens? The body is already moving. The first point was the body was at rest and forces were applied from all the sides, all the directions. And what do you find? The body remains at rest. Now, the second point is something different. So, please elaborate. The body is moving. In this case, the body is moving, right? And what we are applying onto it? The balanced force. What happens? That's all I want to know. Please continue. Hello. Please continue. Hello.
Yes, ma'am.
Yeah, please continue the explanation. Who was explaining better?
After falling through some height, a
No,
stage.
just a moment. Just a moment. I need the explanation. Who was explaining it? Was it Jishan?
Yes, ma'am.
Yeah. Continue better. The body is moving with a constant speed, right? Or constant velocity. What
Yes.
happens? What happens? And we apply balanced force on the body, which is moving with a constant or uniform motion. What happens?
Body body
Yes, the body
continue
continue with the same.
speed and direction.
Exactly. I mean, there's no increase. And what we had learned earlier, if let's talk about Football. The ball is moving with a speed or with a velocity, and you come and kick the ball. What do you think? The velocity increases, isn't it? Hello? And you make a goal, right? Because it was with such a speed, such a velocity that the goalkeeper was not able to hold it. That was unbalanced force. Now we are talking about the balanced force. You got the difference now? What we had learned earlier? That if a moving ball is been kicked by you, it increases the velocity. That's what we had learned because that was unbalanced force. Now we are talking about balanced force. So what happens? The body keeps on moving with the same uniform velocity. Did you understand now? Boys, ninth standard. Ninth standard. Did you understand?
Yes.
Yes. So why? Because this is a balanced force. So your velocity will not increase. It will remain the same. Hope you have understood all of you. Boys.
Yes, ma'am.
So what is the example? The raindrops. So from top it is coming. From clouds it's coming. Okay? So when it starts coming, so obviously it is pulled down by the gravity of the earth. Is it clear? So you can find it increases a bit. Afterwards, let's see. Yes, Septed. Start reading. After falling through some height. Yes, start reading better. Please read. Is off the air, it seems. Can anyone else start reading? Hello, boys. Hello, boys. Can you hear me?
Yes, ma'am.
Yes, ma'am.
Yes, yes. Start to read better.
After falling through some height, a stage called equilibrium occur when downward weight of the drops is balanced by upward force such as upthrust and viscous force.
Then,
The net force acting on the drops will be zero and hence no more acceleration is produced on the drops. Therefore,
continue.
the raindrops move with constant velocity, which was last gained by the drops just before reaching equi-
Equilibrium
equilibrium condition.
condition. So, we are taking the example of raindrops, which are coming from a greater height from clouds. So, when the drop starts coming down, obviously, how does it come down? Due to only one force, and that is gravity. You agree with me? Why it is pulled down? Formation of the first raindrops from the cloud comes down. Why? Due to gravity. All of you agree? Hello? All of you agree? Boys, can you hear me? Boys, can you hear me better?
Yes.
Okay. Now, for example, this is the cloud, okay? And the drops which is forming, the first drops which are forming. are coming down is due to gravity. This much you have understood? Yes? Now, the drops are coming down. After coming down, it gets into a equilibrium stage. Okay? When the weight of the drop and the upthrust is by the air, you know that? We learned about the buoyancy and the upthrust in the liquid. Remember? Fluid. That fluid could be air or liquid. Now we are talking about the upward thrust, that is, air is pushing the raindrop upwards. And the viscous force. What is the viscous force? The density of the water. Have you understood? So all these energies are working onto that stage when we call it as an equilibrium stage. So it balances the downward weight of the drops, the weight of the drop, and the buoyancy or the upthrust and the viscous force, that's the density of the droplets. It is balanced. So what happens? So the net force, the downward force and the upward force, it balances and it becomes zero. So what happens? No more acceleration. That means the velocity of the droplets or of the raindrops which is coming down to the ground does not change. It remains the same as it has started earlier. Hope you have understood. Hello. Boys, can you hear me?
Yes.
You just respond, like it should not be silent from your side. If I ask you a question, will you be able to answer me? In short, I will summarize it later what actually happens. Let me finish this last topic. So what happens? The raindrops move with constant velocity. Okay? Show you how it has to be done. Now this is cloud and the drops are coming down. Here the weight of the droplets and the upward thrust of the air and the density of droplets all balances. All these become balanced force. So obviously what happens? What happens? It will regain the velocity before reaching this is the equilibrium stage. What stage it is? Equilibrium stage. So it will get or it will move down with the same velocity before reaching the equilibrium, and with the same velocity it will come down to the ground. This much have you understood? Boys, I need an answer, better. Have you understood or you want me to redo it again? Should I do it
Understood.
again, beta? Should I do it again?
No, no.
Okay, then can you explain then? Is it you, Jishan? Hello? Hello? Is it you, Jishan?
Yes.
Okay, so can you explain what have I said in just one or two lines?
When rainfall drops
Yeah,
from
when it begins from the cloud, what
when it
happens?
begins from the cloud at a greater height
Why does it come down?
due to the gravity of Earth.
Fine. Yeah, you understood? That is the first point. Then it is
Yes.
coming down, it is falling down, it is falling down. Then at one stage, it reaches equilibrium. What happens in the equilibrium stage, beta? This is the equilibrium stage, remember. What happens over there?
Yes.
What is getting balanced? Say it like that so you will understand. What is the first, what I will take, which force I will take? The weight of the droplet, right? The weight of the raindrops. It
Yes.
gets balanced, yeah, it gets balanced with what? Now tell me.
Thrust.
Upward thrust. Which upward thrust are we talking about, beta? Air. Air is creating a force, isn't it? It is
Yes.
pushing the drop upwards, isn't it?
Yes.
Yes. And the density. What is the meaning of density? How thick the liquid is. That is what is
Yes.
density. It's mass per volume, you know that. So
Yes.
what stage is reached? Equilibrium stage is reached. What stage is reached, beta?
Equilibrium.
Understood now? So it's all balanced force. It is a balanced force. So what happens? The velocity here at which the drop was coming down will be
Will.
continued the same over here. So with the same velocity, when it reaches the ground, the velocity remains the same. This is
Yes.
what I want to tell you. Any problem, boys?
No.
So there will be no change in velocity because it reached the equilibrium stage when all the forces are balanced. So there will be no change in the velocity of the raindrops. Am I clear?
Yes.
Yes. They're small, small things, but very important. If you understand the fundamentals, then nothing, there will be nothing which is called impossible. You will do everything right. Yes, let's start.
Can you imagine the speed of the raindrops while reaching the surface of the earth if they continue to move only under the action of gravity?
So
Suppose
what are
the
we going to
clouds.
find out? Just a moment. What are we going to find out, beta? Sipten, you read the question. Did you understand the question, beta? What they are saying that raindrops, which is coming from the cloud, if it is moving with the action of gravity, no equilibrium stage is reached. There's no balanced forces. Only the force of gravity is applied on the raindrops. What is going to happen? Can you imagine? If the raindrops do not reach the equilibrium stage and only force of gravity is working on the raindrops, what's going to happen? Let's see. Read better. Please read.
Suppose the clouds are at the height h of 3 kilometer and
That
300
is
and
3000.
acceleration u
3000. Write properly, please. It's
3000
3000 meter.
3000 meter acceleration due to gravity g is 9.8 ms square.
Meter per
Initial
second
velocity
square.
u
Septain, please be careful. If you're not able to, you ask me. It is not m, it is meter per second square. Say it
meter
again.
meter per second square. Initial velocity u is equal to 0 meter per second.
Okay. All of you understood this much, or do you want me to explain? Ninth standard. Is this much is clear, or do you want me to explain? Initial velocity of the raindrop is zero, you know that. And then with the force of gravity, it starts increasing the velocity, isn't it? We know gravity is equal to 9.8 meter. The acceleration due to gravity, the way it is pulled down due to gravity is 9.8 meter per second square, right? Yes? So what's
Yes.
going to be the final velocity? Start.
The final velocity is given by v square is equal to u square plus 2g h.
Okay.
H
What we had learned earlier, v square is equal to u square plus 2as. Remember? Remember? So instead of acceleration due to gravity, we have put g. Instead of distance s, we have put height h. Right? This much you have understood? Then, so now we are going to put the values of v, u, g, and h. Let's see what is it. Read it, Rita. That is
That is v square is equal to 0 square plus 9.8 into 3000 is, is equal to v
three
is equal
three
to
thousand.
3000 is equal to v is equal to 171.5 meter per second is equal to 617 kilometer
Per hour.
per hour.
See, here you see there is one thing missing, that is 2. The 2 is missing, remember? So we will put 2 also. 2 into 9.8 into height 3000. We get V is equal to, then we will do the calculation, and V square root of that much amount will be 171.5 meter per second. That is 617 kilometer per hour. So meter per second is converted into kilometer per hour. And I think I taught you already how to do it. Then what will happen? Hello, read.
Raindrops with such a high velocity is faster than a bullet and can
Pierce.
pierce through a human skull.
Skull. So now you understand what's going to happen. If only the force of gravity is applied on the raindrops, we all will die. One raindrop is going to be more than a bullet. It can make a hole in our skull. Can you imagine with such a force it's going to come down? Hope you understand now. And that's the reason that in between equilibrium stage is reached where all the forces get balanced, and with a uniform velocity it comes down onto the earth, so no damage is done to the organisms or human body. You understand? Okay. Now the third point.
Third point, thus the balanced
No,
force
though.
cannot
It is though.
produce, produce
Though.
motion in a stationary body or stop a moving body. They can, however, change the shape of the body. Example, when a ball is pressed between the hands, the forces are balanced, but the ball is changed in its shape and size.
You understood this much? That balance force, we know it cannot produce motion. When you apply balance force, the body do not move. That we have already seen that. Or neither it stops a moving body, but it can change the shape of the body. For example, you take a ball in between your hands and press it. So body is already at rest. We know that, but it can change the shape of the. It will flatten. It can change the shape of the ball and also the size of the ball. The ball is circular. I just press it, it gets a bit flat, not much, but a bit flat, and the size will increase. Am I right? Hello. Do this activity and let me know tomorrow. Take a ball and just press it and see what happens. The shape of the ball will change and also the size will become more. Yes? Will you let me know tomorrow? Hello? Hello?
Yes, ma'am.
Yeah. So this you do that activity and let me know, inform me tomorrow, okay? That was
Yes,
balanced
ma'am.
forces that we learned. Now we are going to learn unbalanced forces, right? So whatever we are doing is all unbalanced forces. Let's begin. Please continue.
Unbalanced force is the resultant of the all the force
Better
acting
read
on a
properly.
body.
Please, September, read properly.
If the
I don't
result
want you to leave any preposition, add any articles. Don't do that. Okay? Whatever is there, please read it properly. Thank you. Start with
unbalanced
it.
force, if the
Forces.
resultant
Hello. It is
forces,
not force, it is
force,
forces.
forces,
Please. Yes.
if the resultant of all the forces acting on body is not zero, the forces are called unbalanced forces.
So what we learned
Unbalanced
earlier, balanced forces, it was zero. Unbalanced forces, it is not zero. So that is the fundamental difference between balanced and unbalanced forces, right? Start. So what unbalanced force will do?
unbalanced forces can move a stationary body or they can stop a moving body.
All of you agree?
Yes, ma'am.
Okay. Continue, better.
When we talk of a force acting on body, we usually
Usually,
usually
usually,
mean an unbalanced force.
so generally, whenever we are talking about any force which is applied on a moving body or on a body which is at rest, what are we talking about? Always unbalanced force. Is it clear? We are not talking about balanced force, but we are usually talking about unbalanced forces. Yes, better. Read.
And the total force on the plane is in one direction. The force is called unbalanced.
Read.
Unbalanced force changes the motion of the plane. For instance, when thrust is greater than drag, it is the unbalanced force that causes the plane to speed up or accelerate.
Accelerate. So you can see over here, when the total see how many forces are applied on the plane? Weight, lift, thrust, drag. These are the forces which is applied on the plane, right? And total force. All these are making it move ahead. Do you agree with me? Do you agree with me? All the forces, the lift, the weight, the thrust, drag, everything is making it move ahead. Is it going back? Does the plane go back? No, so it is going ahead. So it is a cumulative effort. It's the complete force which is making it go ahead, right? So it is moving in one direction. You agree with me? Hello.
Yes.
So which force are we talking about? Unbalanced force, right? It is not balanced. It is unbalanced force. That's why it is moving. Had it been balanced, do you think it will move? It will not move. Now you got my point? Yes? So when thrust is greater, thrust is this one. When thrust is T is greater than drag, that is D, because drag is pulling behind and thrust is making it move ahead. This is the unbalanced force which makes the plane to speed up or accelerate. You got my point? And then the plane moves ahead. Yes, but read the last stanza.
In addition, as the velocity of the plane increases, the lift force increases and becomes the unbalanced force that causes the plane to fly.
Okay. Along with all this, forces, the velocity of the plane increases by the lift force. When the velocity increases, the lift force also increases because the plane is going up. And what happens? There is an unbalanced force, and the plane starts to fly. Did you understand the logic behind a plane flying in the air? This is what happens. How the plane flies. Any problem? Any problem?